Today's notes will be on properties of logarithms. For all of these examples, assume that the variables represent positive real numbers. Okay, so the first rule we have is the product rule. So the product rule says if we have the log of a product, x times y, we can expand that to be the log of x plus the log of y. So whatever it is that's being multiplied together, each piece gets its own log, and we put a plus in between those. The quotient rule is the log of x over y. Again, each piece, the x and the y, get their own logarithm, but since you are dividing those variables, it is going to be subtraction that separates each log. Right, and then the last rule we're going to work with is the power rule. So if we have the log of x raised to some variable, what we do is we take that variable that has the power raised to it, that power moves in front as a multiplier. This is log of x. Okay, then we've got one other property that's listed here. You aren't going to see this come up in any of the examples that we give you, but if you take a look at what these are saying, I think it becomes kind of clear what's happening. So you have log base a of a to the x equaling x. If you rewrote this as an exponential, it would be a to the x equals a to the x. So essentially, it's like these a's are canceling each other with this log, and then x just equals x. And then you can see the same thing kind of happening over here, this a as your base being raised to a log with that same base. It's kind of like they just cancel each other out. But again, I don't think that you're going to see that in the homework that I'm going to assign to you. All right, so let's work with practicing those other three properties I showed you above. What we're going to do first, we're going to take a look at number 1. And the directions say to write as a sum of logarithms if possible. What that really means is that you're going to expand it. So if you are expanding, it means each thing that follows the log is now going to get its own log. So in this first example, you've got a product. So you want log base a of 5. So the first part of the product plus, because you're multiplying, log base a of 2. If it was possible for us to simplify either of these pieces, we would. This one, we have variables as our basis, so we're not going to be able to simplify those any further. On number 2, if you give each piece its own log, you've got log base 3 of 9 plus, because you've got a multiplier here, log base 3 of b. You actually can simplify this first piece. And we did this in our previous section when we would evaluate these. It'd be 3 to what power gets you a 9? And that would be a 2. So this would simplify completely to be a 2, because log base 3 of 9 is a 2, plus log base 3 of b. All right, we've got another multiplier on number 4, and then we'll go to number 3. We've got 3 things being multiplied here, so each one of these will get its own log. So we'll do log, and then if there's no base there, that means a 10, so I'm just going to leave it blank, so it implies that it's a 10. Log base 7, or log base 10 of 7 plus log of w plus log of x. And then our last one in this section, we've got a power here that's going to come in front as a multiplier. So 4 times log base 8 of w. Okay, so that's expanding. It's when you're given a single logarithm and you have to write it as multiple logarithms as a sum or a difference. So if there is a product, you're going to have addition in between them. If these had been divided, this would be subtraction. Okay, and then the next section wants us to go from multiple logarithms down to a single logarithm. So basically we want something in number 5 to look more like number 3. We call this condensing. All right, so we want to write this as 1 log. So we have to take a look at the operations between them. So this is log base 12. You've got addition. So it means that you're going to take the two things that follow the log and multiply them together, because that's what this addition means when it is expanded. So it's 12 times 4. Go ahead and multiply those together, and we get log base 12 of 48. In number 6, we've got addition in between. We've got the same log bases here. So we're going to do log, and it's just going to be 18 times W. All right, and then the last one of this section, again, addition here. So it's going to be log base 4 of these two terms multiplied together. So log base 4 of P times 2P plus 3. All right, moving down to 8 and 9. 8 and 9, look at the directions. Write as a difference of logarithms and simplify. So again, this is expanding, meaning I want to go from a single logarithm to multiple logarithms. So that division tells me I'm separating the log base 5 of 8 and the log base 5 of 11 by a subtraction. That's the quotient rule. So these quotients, okay, this quotient, this numerator divided by this denominator, separating that, you put a subtraction in between. Same thing on number 9, log base 8 of 16 minus log base 8 of r. Okay, let's move to the next page. Okay, writing as a single logarithm, this means condense. So we're going to have a log base 3, and then you're going to have 27 as the numerator. What follows the subtraction is the denominator. So log base 3 of 27 over 8. If that was something that you could reduce, you would reduce it. In number 11, you've got log base 7. Your numerator will be x plus 5. Your denominator follows the subtraction sign, is x plus 1. Okay, now let's work with that power rule on numbers 12 through 15. So here, this 3 is going to move in front. So 3 times log base x of 9. In number 14, I know I'm skipping 13, I'll come back to it. Right now we don't have an exponent written on this, but if you change the square root of 6 to be 6 to the 1/2 power, then you can move that in front as a multiplier. So we just changed from a radical form to an exponential form in order to be able to pull that exponent out in front. We'll do the same thing on number 15. Right now we've got this x to the 3rd in the denominator. Okay, so if we want to move this back up, we're going to do the negative exponent. So this is log base x of x to the negative 3rd. Because negative exponents, we use reciprocals. So if we're given this 1 over x to the 3rd, it means it was x to the negative 3rd. And now that it's separated, this negative 3 can come in front. And this is 3 times log base x of x. So this is saying right here, x to what power is x? Well, it's just a 1. Sorry, I'm missing the negative there. That's negative 3. So this that I've highlighted just becomes a 1, and then we've got that -3 in front from our exponent, so -3 times 1 would be -3. And if you look at what happened when I rewrote this from this fraction to a negative exponent, you could see that these two were going to cancel, and then this is your answer. All right, one more where we're going to have to do some simplification here. We take this 5 and we move it in front. This is going to be 5 times log base 3 of 81. So this base 3 of 81 is something I can simplify. 3 to what power would be 81? That would be a 4. 3 to the 4th is 81. So this log simplifies, and then I have 5 times that 4, which is a 20. Right, so you have to pay attention when you've simplified these. If you have a base that is a whole number, you have to look to see is the what you're taking the log of some power of that number. You're okay in number 12 because you have a base of x and then you have a number, and in number 14 same thing. But when you've got a base of x and then you're taking the log of x in number 15, you're going to have to do some more simplifying. All right, so let's continue to the next section where we're just going to do some evaluating. All right, so one of the properties on the front that I showed you was the log base 9 of 9, and how these can be canceled. I'll show you why that works. Two different ways you can do this. You can actually set this equal to x, and you can rewrite it. 9 to the x equals 9 to the third, and your bases are the same, so x is obviously going to be 3. Or if you rewrote this and moved it in front, you'd have 3 times log base 9 of 9. 9 to what power is -1? So 3 times 1 would be 3. I think that what I've done in the green, the first way that I did this, is probably more familiar to you from the last section that we did. So let's carry on with that in number 7. So I'm going to set this equal to x. Remember, if there's no base written here, that's a 10. So it's 10 to the x is 10 to the 7th. So x is just 7. Okay, so if that base of your log and then what you're taking the log of, if those are the same, it's like these cancel. Okay, and then we're going to do that same kind of shortcut here in number 18. It's like these cancel out, and our answer is 4. All right, so putting those all together and trying to simplify some expressions that have multiple properties together. So write each expression as a sum or difference of logarithms. That means expand here. Expand. All right, so we're going to separate first the product. So I'll do log base 4 of x to the third. That's the first part of the product, plus log base 4 of y. And then I'll take this exponent and move it in front. So this is 3 times log base 4 of x plus log base 4 of y. On number 20, you're going to have log written 3 times. You're going to have log written for 81, you're going to have log written for a, and you're going to have a log written for b squared. All right, so we're going to do that part first. Log base 9 of 81. We're going to do log base 9 of a and log base 9 of b squared. So each piece that follows the log will end up with its own log. The confusing part here is that you've got two things that you're dividing by. So when you have a quotient, okay, when you are dividing, what follows the, or what happens when you're dividing is everything that is underneath this fraction bar, everything in the denominator has to have a negative sign in front of it. So since we have two terms in the denominator, they both need to have negatives in front of them in order for them to both be classified as in this denominator. Okay, because basically you've got a product here, but you need to divide by both of these things. So it will be a negative in front of a parentheses with an addition. So instead of having to deal with the parentheses and distributing, just remember anything that goes in the denominator will have a negative in front of it. And then there's two things we need to clean up here. This exponent on this last term needs to go in front. And then also 9 to what power is 81? That's a 2. So the complete simplification here would be 2 minus log base 9 of A minus 2 times log base 9 of B. Okay, 21 is a little tricky. It's tricky because I have a square root around this product. So I'm going to rewrite this as log base 5 of 5t to the 1/2 power. So my first step will be to take this 1/2 and move it in front of my log. So I've got 1/2 log base 5 of 5t. And now I've got a product inside here that I need to deal with. So I've got that 1/2 still in front, and then I'm going to give 5 its own log and t its own log. So log base 5 of 5, it's a product, so I'm adding, and log base 5 of t. One other thing that can be done right here, log base 5 of 5 is 5 to what power is 5? That's a 1. So the complete simplification here, if you want to keep it in these with these brackets, you can do 1/2 1 plus log base 5 of t. Okay, we got one more left. Kind of trying to trick you here. So what we have happening in the parentheses is addition. I don't have any way to expand this. This is already simplified as much as it can be. I have rules like number 19 when I have a product. I have rules like number 20 when I have a quotient. And I have rules when I have a power. I don't have any rules to break up addition between logs, only multiplication, division, and powers. Okay, so 22 is a trick. You cannot expand that. All right, moving down to the last part here. The last part, writing as a single logarithm, means instead of multiple logs, I'm going to condense to just one log. So I'm going to need to take that number in front and write it as a power. So this will be log base 6 of 9 squared plus log base 6 of 2. 9 squared is 81. And then I've got an addition sign here, which tells me that I need to multiply what I'm taking the log of in both of those separate terms. So log base 6, and this is going to be 81 times 2. So this is log base 6 of 162. All right, we're going to do the same thing over here on number 24. Take these numbers in front and make them exponents on what follows the log. So we've got log base 3 of m to the 1/3 power plus log base 3 of m plus 1 to the 4th. So now you've got addition between these two logs. It means that you're going to write these as log of a product. So that's log base 3 of m to the 1/3 power times m plus 1 to the 4th. And I know that looks a little weird, but let me put a bracket around this so that it's very specifically shown that you're taking the log base 3 of that product. Okay, that does it for the properties of logarithm notes. Now you're going to move on to your practice. Have a great day, guys.